function? Can somebody define? I guess this also we have somewhere we have read about this, right? Increasing function.
A function when x1 is greater than x2, greater than equal to x2 means
Yeah, for any function f r to r, if x1 is less than equals to x2,
then that means f of x1 is less than equal to f of x2.
correct. Okay, this is what generally we mean by a increasing function, right?
Yes.
It's, for example, this is a pretty simple function. This is increasing, right? If you'll just take one x1 here and one x2 here, if x2 is greater than x1, you can see that fx2 is also greater than fx1, correct? So when x2 is greater than x1, you can see that fx2 is also greater than fx2 is pretty this length, and then this is fx1, so fx2 is greater than that, so you can directly say that. What do you mean by a strictly increasing function?
There is no possibility of equality.
Correct. So is this a strictly increasing function?
Yes, sir.
Yeah,
Yeah,
this is a strictly increasing function, right? This is strictly increasing function. So is this clear to everyone? What is the difference between strictly increasing and increasing function? Basically, for the strictly, what is the difference? Like if this is what you are getting. So for a normal increasing function and for a strictly increasing, we'll be having, so the equality won't hold. So that means not even for, like, you can't get 2 points where the function's values are same. So let's, for example, this is what I was, a function you have, this is increasing like this and then this is going. So can you tell me whether this is a strictly increasing or a just increasing function?
Is increasing, not a strictly
increasing.
increasing.
Yeah, it's an increasing function, it's increasing, but for some particular value from here to here, even though we were x1 and x2, we were increasing, the function value was almost same, right? Like same. That's why it's increasing function, but it's not a strictly increasing. Strictly increasing means you can't get that equality sign won't hold. Okay, and then the same case is for the decreasing function also. So if x1 is greater than x2, greater than equals to x2, that means fx1 will be less than equals to fx2. Okay, this is all we have discussed, I guess, somewhere in week 4 or 5. Okay, so I don't think so there will be much difficulty in understanding this all topics. Okay, is it fine? These all things are fine, right?
Yes, sir.
Yes,
Yeah.
sir.
Okay, and then we have discussed about some of the basic function, trigonometric function, right? Okay, like sine x or cos x or tan x, right? These all function we have just discussed, and hopefully everyone would be aware of what do you mean by like a sine function and cos function. It's like simple. Okay, can you tell me how do you plot sine x? Like basically it goes somewhat like this, right? It's a periodic function. Okay,
Yes.
and similarly for the, I don't think so this all things should be discussed, but okay, it's fine. Let's move to the next part, which I guess would be that was there. So that's why I told you that this week doesn't have much content. Yeah, whenever you'll go mix this week 7 and 8, then we'll go through some of the concepts like continuity, differentiability, and all. So let's discuss the tangent. I guess tangent function is also been discussed. Okay, can you tell me what do you mean by a tangent at some particular point of a curve? Okay, what do you mean by a curve? First of all, what do you mean by a curve?
path of a moving point
Correct, path of a moving point.
on coordinate plane.
Okay, that can be anything. Any path can be a curve. Okay, And what do you mean by a tangent at some particular point? So tangent, what does that tangent defines?
Tangent define the tendency, means it shows that instantaneous direction at a point.
Correct. Correct. So it generally tells you the instantaneous direction at that particular point. Okay. For any curve, it generally tells you the instantaneous direction in which it is moving. Okay. And if you are able to plot a tangent at like n number of points on the curve, you'll see that you are basically drawing the curve itself. Okay. If you are drawing n number of tangent at each particular points, right? It's, for example, you have a curve somewhat like this. Okay. So if you are drawing a tangent at every particular points, you'll see that you are basically drawing this plot itself, right? So if you have to calculate a tangent, for example, you have a curve somewhat like this. And you have to, is this a tangent? Which of them is a tangent? A or a B?
B.
B is a tangent.
Yeah, B is a tangent, right? Anybody has any doubt in this? And tangent and all, it's like pretty simple concept. Is there any doubt in this? No, right?
No doubt, sir.
Okay. So you can have, okay, so tangent basically tells you about the instantaneous, the direction, the instantaneous direction in which the plot is moving, or the curve, whatever you want to call that, is moving. And if you are drawing the tangent at like n number of points on the curves, in the end you'll get the curve itself. Okay, this is what the tangents tells you. Now if you have a, so greatest integer function, you already know, right? Greatest integer function.
Sir, but in the previous one, how do we know the direction? We know that, okay, that's a tangent and that's a curve. But how do we know the direction?
Yeah, this generally tells you the direction itself. The tangent itself gives you the direction, instant direction at that particular point of the curve. Because see, that should
No.
not touch any other points. It will just touch only one single point at that particular point.
Right.
Sir, I have a perspective in this. May I go ahead?
Yeah, sure.
Okay. Look, what a curve is like a path traced by a moving point. Yeah. And when we are drawing a curve, it is moving in certain direction as we are drawing it.
Correct.
So if just extending a particular direction at each point, then that is a tangent to that curve. That what means I understood by a tangent thing.
Okay, can you come again? Can you repeat that?
I'm saying curve is a like path traced by a moving point.
Correct.
So when we are drawing a curve without lifting a pen, we are moving in certain direction at all the points on the curve as we are drawing.
Yeah.
So when we are drawing it at each point, we are moving our pen in certain direction.
Correct. Yeah.
So at that particular instant, when we are which direction we are moving the point, that forms its extension forms the tangent.
Correct. You can say that also.
But see, while drawing the curve, I know the direction, right? But if I'm looking at that curve and that tangent, how do I know that the curve is moving up or down? How do I know the direction through a tangent? Tangent is a line passing through that point.
Yeah. Tangent. See, if you have let's, for example, this is a straight line. How will you plot a tangent in this at some particular point here?
For a straight line, it would be the tangent would be the straight line itself.
Yeah, so straight line itself, right? So that means what? It is just saying you the instantaneous direction also, right? At any particular point, you are just calculating a tangent that will be parallel to, like, not parallel, that will be the exact same line itself. right? That's the tangent at that particular point, correct?
Right,
And that's
but
the direction also.
but direction is something like if you're moving up or down, right? I can take that point and draw a tangent saying going upwards, and then I can draw a tangent going downwards. So I don't know the direction, whether it is going up or down, but it is going somewhere. I know for sure it is moving.
Say
My
when we
problem is with
define
the
the
definition of direction. My problem is with the definition of the direction. Tangent, how
okay
can
to
tangent tell me the direction?
so shall I
Yeah, go ahead.
my perspective. So, we define the direction of a curve in coordinate plane based on its slope, right? We
Yeah,
know the 2ax plus b is the slope of a quadratic function, and that slope defines the direction of the quadratic function at a particular point. So when we uh, draw a tangent at a particular point, that tangent it is basically y is equal to mx plus b. So that y is equal to mx plus b is based on the slope itself. If it goes upwards, then the slope will be positive, and if it goes downwards, then the slope will be negative. So that's why tangent is defining the direction of the curve at a particular point.
correct. See, whatever he said is totally correct. Like whenever you are drawing some tangent at some particular point, you basically takes how do you take the slope? You basically differentiate it to get the slope at that particular point, and that slope itself will give you the instantaneous direction, right? Correct or not? See, at any particular point, whenever you draw a tangent, so you take some slope, right? You should be having some like in
Right.
which direction or some slope you are taking, and that slope itself gives you the direction. And how do you calculate that? By use the, maybe you can calculate that whatever he said, saying that n slope value by the mean of differentiation itself, and that differentiation itself gives you the direction in which the plot is moving.
And
Okay.
so can we
Yeah.
also assume, right, or maybe like a principle that your curve always move from minus infinity to plus infinity? You
Yeah.
always go left to right, correct?
No, there can be a curve like this also, right? Circle can be your curve also, right?
Right.
But when you plot on an axis, sir, you go from plus in generally by default you always move from left to right, right?
That is fine, but for this type of
Yeah,
a circle,
but
if
tell me which direction it is moving at the topmost point, right? At the
yeah,
topmost
top,
point, it can be left, right, anywhere.
No, so if
But
it is anti-clockwise, right? But I'm saying by direction, right? Or otherwise it will be specified, right? Now
but
if you put a circular, you have to bring another parameter there, right? Whether it is anti-clockwise or clockwise, correct?
if I have to calculate a slope at this particular, how do you calculate? You'll just say like this, right? This is the direction in which, if you are taking from anti-clockwise or clockwise, that like, see, if you are coming like, if you are drawing like this, that also the slope will be the tangent will be somewhat like this, correct?
Mhm.
But
That
slope
means,
and direction are associated, sir.
Yeah, that is what I'm trying to relate. Yeah,
I
the
don't
point
think there is an
there.
association between a direction and slope, right?
Yes.
Slope is all about your angle with your x-axis, right?
No,
correct.
No,
no.
no, 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 no.
Consider this case here. On this circle where this sir has drawn the tangent line, if we move along the circle, whether it's from the right side or the left side, we are still getting the same tangent. And this tangent, the theta that it forms with the x-axis, that is your slope. Yeah, tan of that theta is the slope, na?
Yeah, correct.
So whether we move from the right side or the left side, the instantaneous direction of the point, the line that the tangent is going to form is going to be the same. So the slope, theta that you get with the x-axis is also same. Means that tan theta, that is slope, will also be unique because you are only getting a single tangent.
See, basically, see, this is what it's representing. The tangent at this particular, for this, basically this curved circle at this particular some point A, is a line basically which represents the instantaneous direction in which the curves moves at that particular point A, right? If you, I don't know what's the confusion here, but let's, for example, you're just drawing a slope here, okay? It is at this particular point, if you'll think that how it is moving the circle, it will be somewhat like this. You can take it from this side or that side, doesn't matter. You'll get the same slope, like the same tangent, right? And the slope, if you have to calculate, you can take the tan theta and you'll get the unique only at every particular point. If you're calculating at this point, you'll get a unique slope. At this also, at this particular point also, you'll get a unique slope, right? And if you will drop n number of tangent, you will get the curve itself.
So, yeah, sir, one thing is vector is also part of mathematics course.
Here we are not discussing about the vector.
No, I understand, sir. I'm just checking because generally,
Yeah, math too.
when we
Math
talk
too.
about direction, we talk about vectors, right?
Correct. But here, that's why I'm saying that you don't have to go into the minute things. We will discuss the vectors also, but in the upcoming courses.
Okay, so no, just to confirm that. So if you need a direction, vector would be
A
maybe the
better
right,
idea. Correct.
right, to talk about. So I think we are right now directionless, right? Maybe if direction has to be coming, vector would be the right, maybe the concept to associate that.
Yeah, you are correct in this. So what I'm trying to say is, like, here you can just get an idea that if you have to calculate any, like, you just can have an idea that for any curve, and if you have to draw, so tangent generally gives you some at that particular point, how does that plot moves, and at that particular point you can get some sort of a line or a tangent at that particular point that gives you a direction, that instantaneous direction at, and yeah, there can be a confusion that how are you drawing a plot, whether it's anti-clockwise or clockwise, but that is not going to change the tangent, right? Is this clear or not?
Yes, sir.
So sir,
Sir, as long as we have the direction of the circle, then the tangent at that point gives the direction of the
But the line
point
that you
is
are getting
moving.
will be same. Yeah, the line that you are getting
Yeah,
at each particular
line
point
will be the same. Yeah, line will be the same. The direction will be according as the point is moving, and where the if we plotting the tangent at that point, then that point's behavior shows can be shown by the tangent at that point.
Correct. So even the slope, whatever you'll be getting, right, that will be also unique. It will be same for each particular point. That also won't be different. Like whether it's going from anti-clockwise or clockwise, that doesn't matter. The slope that you are getting with the x-axis will always be same for a unique point. Okay.
Yeah.
And one more, like whenever you are plotting a tangent, and whenever you are making a, what do you call that, parallel line parallel to the tangent itself, either should be cutting more than one point. Okay, so whenever you are, let's, for example, this is a tangent at this particular point, and whenever you are drawing a parallel line to the tangent, either it will be crossing at more than one point, okay, or it should not be crossing, because here whenever you're drawing a tangent at, so you basically are drawing a tangent at some particular one point itself, okay, so that should not be cutting more than like 1 point. Okay, is this clear? So that's the, whatever you want to call that the characteristic of a tangent line, or whatever you want to call that. Whenever, so I'll repeat it again, for any particular point, if you are drawing a tangent line and then you are taking a parallel lines the parallel lines to the tangent, either it should be crossing more than once the curve, or it should not be crossing. Okay, you can't get any other, like you can't get any parallel line that is just passing through one single point itself. Okay,
Yes.
is it clear?
Yes.
So but the tangent itself can also pass through multiple points, right? That's what was told in the video.
What? Okay, if it depends, if your curve is like a very like compact curve and all, so then it can happen. Yeah.
Okay, so
but normally whenever you'll deal with the functions, that will not cross. Most probably it will not cross, but okay, if your curve is like very like compact one, then you can get it. But normally, whenever you are dealing with its mathematical function and all, will be just touching a single point itself. Yeah, go ahead.
So, sir, I got the point, right? So if I draw a curve and I draw tangent, if I draw X number of tangents, I can get the curve itself, which is
Correct,
true,
correct.
right? Which
Yeah.
is true. I don't have a doubt over that. I don't have a doubt that the tangent would pass through the point and we can get the slope.
Mhm.
But what I am still trying to comprehend is the direction part of that one, which could be like you said, right? I could get the tangent, one tangent, and I could be moving from top to bottom or bottom to top, right?
Mhm.
So how do I know the direction, whether I'm moving up or down based on the tangent itself is what I'm not completely sure.
Okay, so you want to know like that is like, see, if you are just dealing with the straight line itself, you'll not be able to uh, differentiate between whether I am coming from left side or right side. That you
Right.
can't be, because there you have to use the vector form to know the
Yeah.
exact direction, right? Here
So
we are just dealing with the tangent, the line, or you can say the whatever we are saying, that instantaneous direction. That also itself, if you want to know the exact thing, you have to deal with the vectors. Okay.
Mhm.
Yeah.
Okay.
So that we will be discussing, but not at least for this course. We'll be discussing in the upcoming courses.
Okay.
Yeah. Here,
Yeah,
I,
when the derivative will be our course, then that tangent part will be the more clear.
correct.
Because
But
with the
here,
with the
yeah. So
derivative,
here, why do we
yeah.
introduce tangent? It just give an idea, like how will you to just get an idea about, because in the upcoming weeks we are just going to deal with some of the concepts of the differentiability. Okay, so for the differentiability you should be knowing the basic concepts of the tangent, and for the continuity also. So that's why it has been introduced here. Okay.
Sir,
Okay.
Yeah.
sir, tangent should pass through at most one point only, right, through the curve. If I draw tangent to a circle at a particular point, then it should be perpendicular to the radius.
Yeah, for a circle it
Only
should be perpendicular. Yeah.
a tangent to a curve should pass through one point only. At different points on the curve, tangents will be different. Then how can a tangent pass through more than one point? If in this case, in this coordinate plane, no, there is
No,
only one
that
tangent.
is why I'm saying that mostly
And
whenever you'll deal with most of the function that you are dealing, whenever you are drawing a tangent, it will not be crossing at any particular, like it will just touch a point. Okay, if it is a crossing, that is not a tangent itself. But for
yeah,
some cases, because in the curve, like somewhat like this. Okay,
yeah,
if you have to
irregular.
plot this, right? So it depends on how is that plot, whether it's in the 3D or in the 2D itself. Okay, in the 3D, maybe there's a possibility that the curve that you are drawing itself is, it's like whenever you're representing the 2D, that's why you are saying that whenever you'll get the tangent, it is crossing a point. Maybe this is in the 3D, right? And then it's not crossing. So this type of plot we will mostly will not be dealing with. Okay, we're just dealing with the simple plot where, and that's the most important point about the tangent, that it should be touching only one point at, like for a function itself. Okay, it will not be touching any other point. If it's touching, that's not a tangent itself. Okay, it's an intersection, like different things of, like you'll be getting. But for the tangent, just touching a single point of a particular function, okay, then only you can say that as a tangent, because tangent itself tells you about the direction at some particular point. Okay, if it's crossing some particular like point itself, then it's not a tangent itself. Okay.
Okay. So I didn't understood about this closed.
This one.
Yeah.
Okay, so what I was
What
saying is
happens if we draw the tangent internally?
tangent internally. Okay, so
Yeah, but
that's why I was saying, so do not get
Right.
confused with those here. Those type of
That
functions, those type of column will not be dealing at all. Okay, will
yes,
be just
that one is the 3D thing.
You can think of as a 3D also, or so that's why I'm saying those type of function the curve will not be dealing. Okay, we'll just be dealing wherever for all those function you'll be just, if you are plotting a tangent at some particular point, you're just touching a point itself. It will not cross any other point. Okay, so do not get confused with those type of stuffs. I guess in the lecture maybe there was a curve, he just took it. Okay, so yeah.
Okay, so that's generally clear. But what happens if in the case of the closed surface?
Which closed surface? Yeah, this is also closed. The
like
circle is also a
the
closed one.
one you have drawn previously.
Yeah,
at
we'll not be
tangent
dealing with
what
those
happens to that
curves
tangent.
also. We'll not be dealing with those curves. Okay.
Okay.
Yeah. What else has been discussed? Okay, so the tangent has been discussed, and then let's discuss about the so we have discussed about the limit of a sequence.
Sir?
Yeah.
So before this, can you please explain about floor function? So
Okay.
after that, we can.
This is GIF function, right?
GIF function.
Okay, so you call it as a floor function. Okay, that is fine. So basically, what happens in the floor function, it will be getting somewhat like this, right?
Yeah.
Okay. So what does that mean? This is 1. Let's, for example, this is 2, and this is 3. This is 1, 2, 3, and 4. So this function, the greatest Indian function, is like whenever your value, okay, so this generally limits your value whenever you are getting somewhat like this from 0 to 1. Okay, whenever your values x belongs to 0 to 1, your exact value, the y, will be what? 0 or 1?
0.
0.
Correct. 0. It will be 0. Okay, whether 1 is included or not?
No, sir.
1 is not included. Correct.
The second step.
Yeah, whenever your x belongs to 1 to 2, then what should be the value of y?
1.
Yeah, 1. Correct. And here also this 2 is not included, right? Similarly, here 3 is not included, 4 is not included. This is what you call that. Whenever, let's for example, you are getting 1.3, then what should be the value of y? 1. Correct. So from 1 to 2, whatever the value you are getting, it will just floor function is like, if you are going above this value till 2, it will just drop it to 1 itself. Okay, and if you are getting from 2 to 3 any values, it will just drop it to 2 itself. Okay, but if you are getting 3, then it will be getting 3 only. Can you tell me, can you plot a tangent at this particular point?
No, sir.
You can't plot it, right? Because you can see that, right? You can't plot it because if you are coming from this side, left hand side, the direction will be different, but if you are coming from the right hand side, the direction will be different, right? So that's why you can't plot. Can you plot it here at this particular point, 2.5? Here you can plot, right? The tangent will be almost parallel to this point, because you can see that here from left side or right side, both the direction you are getting the same tangent line. Correct?
Yes.
Is it clear, right? So at 2 you are not able to, because you can see that whenever you are just tending from if you are coming from the left hand side, the tangent, the direction is different, because you are getting the 2, like you are tending to 2, but whenever you are just you are tending to 1 itself. But if you are going a bit more than 2, and then if you are finding the direction, the tangent at that particular, here the direction itself totally changed, right? Here you are getting the different tangent, here also you are getting the different tangent, right? So that's why you can't get, because you are coming, whenever you are coming from left hand side or right hand side, both are, you are getting the different thing. That's why you can't plot it at 2, but you can plot it at 2.5, right? Because whenever in closer to 2.5, or whether you are coming from left hand side or right hand side, you are getting the same straight line. Is it clear?
Yes.
Sir, here you have written x belongs to 1 comma 2. Here
Hmm.
1 should be included.
Yeah, one is included here.
Okay.
Here also the 0 will be included. Yeah. Okay. And what about the negative values? If the values is from -1 to 0, what will you get?
-1,
Minus
lower
one.
one.
You get
-1.
-1. Yeah. Similarly, from -2 to -1, you'll get -2. So I guess this is clear, right?
So can you take an
Yes, sir.
example like when can this be applicable?
What?
So can you take some examples? When can this function be applicable?
In a lot
Where
of places. In a lot of places, like generating random numbers, right? When you generate random numbers of decimals, then you want to round it up to the first digit, right? That's what you will do, floor function.
Yeah, there
Or
also you
string
can
function.
use it, right? You don't want any values in the decimal form, so you just give it this as a function, right? Whenever you're coding or something, you can just give it as a greater than the function, and then it'll round off every value. So even though you were getting 2.98, it'll round up to 2 itself. Okay, that's a debate different. Like we can talk on that, like why from 2 to 99 to 2, like. But if you want to do that, you can want to use that the floor function, you can use it there. Okay, there can be some like utility for this function itself, right? Some or other places. Okay. Can you get the direction? Can you plot a tangent for this curve when there's a sharp bend at some particular point 1 or 0?
No.
Because you can see that right here the
Direction is
slope direction is this one, but here it is this different. So at this particular point you can't get it. But apart from this, for any other values you can get it, right? You can draw the tangent.
So direction does not really mean the direction. It means the curve itself, following the curve itself.
Yeah.
Okay. Okay. That makes
Okay.
sense.
Yeah, whatever you have said is correct. Like the curve, it's the direction with the curve, it's like whatever you want to call that. It's, for example, if you are drawing a tangent at this curve, so that means the direction of the curve. Okay.
Right.
And here also the direction of the curve itself.
It doesn't really mean north, east, south, west. That doesn't mean. It means just following the curve itself.
Curve, yeah.
As
Correct.
long as you can draw continuously tangents, that's why you can follow the curve. Okay.
Correct.
I think that makes.
Okay. So is this clear, that the gradient function, the floor function? Is this clear?
Yes, sir.
Except for one part,
Yes.
sir. You said GIF. What was the GIF?
The greatest integer function.
Greatest integer.
Okay. So let's
Sir, so that means this floor function is applicable for decimal numbers.
see.
To round up.
We can discuss about the utility, where it is used, where it is not used. That's a different case itself. So if you have been given a function like this, where you have been told that whenever the values is greater than, like whenever the values is from 0 to 1 or from 1 to 2, so whenever you are getting some decimal values, you're just taking the value to the downward, to the floor value itself. Okay. Is it clear? So that is basically your floor function. Utility can be, you can have a different aspect, like you can use it at different places. Okay. And there are some lowest integer function also, but as it has not been discussed, we are not discussing those functions. Okay.
That means this floor function is defined on integers only.
No, for any values, right?
Any value.
See, so what we have told
Then
for
we have
x,
to convert into decimal.
for any values, let's for example that n is some number n plus 1. Okay, that basically from n to 1. So what do you get? You'll get the greatest integer function as n, right?
So how greatest integer? I don't
Okay,
understand.
floor
We have
function
to take
itself, floor function.
lower near from.
Floor function.
Okay, yeah.
Okay, or you call that as a step function. So many names are there for this function. Okay, see,
That
so whenever you, so there can be one utility like let's for example while whenever we are posting something, right, whenever we post something, so that generally we post it on the basis of kgs, I this, right? So whenever your product is between 1 to 2 kgs, they'll charge you somewhat like for 1 kg itself, and if it is from 2 to 3 kg, they'll charge you for 2 kg. So this can be one utility from where, like, where you use this, like, step function or floor function, right?
okay.
Yeah.
So if I take integer like 2, then the floor function of 2 will be 2 itself.
Yeah, that will be 2 itself, right?
Yeah.
But if you are taking any values greater than 2 and less than 3, including 2 itself, like 2.99 also,
Like
it will take that functional values to 2 itself. Okay, that's why it's called a floor function. So whenever your values is from 2 to 2.99 also, the values, the y that you are getting will be 2 itself.
Okay, round off is also a floor function, right? So round off between 2.5, even if you take just, right, if you take round off to the nearest 100, right, that is also a floor or a seal function, right? Depending on whether
It
it goes
depends on how do you take that. Like rounding of some, one can take rounding of as like whenever the values is greater than 2.5, it will round up to 3.
right.
But it
And
depends on how are
that
you
will become the
rounding of
seal
the
function.
values.
That will become the seal function, right? Just opposite of this one, the floor.
Not exactly, because whenever you are getting from 2 to 2.5 also, that time you will round off to 2, right? The
Yes, so
exact
that's what
opposite
I'm
is a
saying,
different
right?
function. Yeah. That exact opposite is a different function where you'll sell off to, whenever you are getting the values from 1 to 2, you'll round off to the 2 exactly. But here what we are doing is, whenever we are getting the values from 1 to 2, we are just putting the values as 1. We are just pulling that value as 1 itself. Okay, from 1 to 2, we are not including 2. But if it is including 2, so again it will push to 2. Okay, so from 2 to 3, it will pull it to 2 itself, including 2. So from here itself, you can see that, right? This plot itself is not that difficult to understand. See, from 1 to 2, whatever values you are taking, it will just pull. Even though you are taking any values, it will just pull up to 1 itself. You can think of as a straight line. Okay, but whenever the value is from here to here, it will just pull up to 1. Sorry, 0. Whenever the value is from here to here, it will pull up to here itself. Is it clear now?
yes, sir.
Yeah. Let's yeah, so till now, if you have a doubt, is there any questions that has been asked in the so one guy asked me about the question 7.3, question number 8, I guess he has asked. Question number 9 he has asked. 8 you have asked, right? Okay, so there is a question. You can just see that. You have to tell me which of the following options at P is there is no tangent. Are you able to, so at P point, can you plot out tangent at P?
No, you cannot
At Q
plot the
also?
tangent at any of these points, Q, R, S.
T? You can plot, right?
T we can plot.
Yes.
The same way.
Yeah. And the other question is, okay, I guess these are all pretty simple questions. I don't think so. It's like, okay, the 8th point is, let A be a set points where the curve has no tangents. I guess this is related to some other questions, right? So who was asking 7.3 question number 8?
Me, sir.
So this question is related to some other code, like question, or it is independent of?
Sir, actually, I'm not able to get, sir, what is lower bound, sir. It asks for, just wait a minute. Yes, sir, am I audible?
Yeah, you're audible.
Yeah, sir, in that question, it says if A is a set of point on the curve C which has no tangent, so find the lower bound for the cardinality of the set. So I am not able to, what is lower bound?
Lower bound is the minimum values of that function.
Okay.
Yeah.
Okay, sir, there is another question from activity 7.2.
Hmm.
Just wait, sir. Question number, sir, second and third. Sir, I applied the same method which is applied by the instructor in the video, but I got the wrong answer.
What is there? You have a two function, right? Fx equals to x square plus 2x plus 3, and then you have gx equals to x plus 1. Use function f and g and answer these questions. What has been asked?
Sir, in the question, there is an error for this one.
For
Okay.
second one.
Yeah. So
Yeah, for
you,
this one. He asked for f plus g of x, and I got 11. That's correct. But
here it is asking f upon g, right? Of 2.
oh, sorry, I got this is 11. So, and for the second question is incorrect. I'm
So what
getting
I
3
do,
fg of x.
sir, what
Okay.
I do first, I put 2 in f and g, then I divide them, then whatever value I get, then I multiply 3
Why did you multiply? Okay, you multiplied 3.
because
Then,
here is 3.
then what is the error you are getting?
I got 15, but the answer is 11.
Yeah, sir, I got 11. So just put the f and z at in which way, like f by g as a function, and put the 2 in the function and then multiply 3. You will got the 11.
What's the error here? Like if you are putting, let's for example, you are getting the value x square plus 2x plus 3 upon x plus 1. Multiply it with 3. Put the value 2 here.
Yeah, you will get the 11.
Now, if you are putting 2 here, 2 you have to put, right?
Yeah,
So
4 plus
4.
4 plus 3.
Yeah,
Upon
by 3
3.
into 3.
3 will be
This gets
cancelled out.
cancelled. So 11 you are getting.
Yeah.
This is simple, right?
Sir, in the second sub question, it was asked fg of 0. I'm getting 3, but the correct answer is 6.
Okay, so if you are putting x square plus 2x plus 3, right? And in that x you are putting x plus 1 ka whole square plus 2 x plus 1 plus 3. If you have to put what? You have to put 0, right? So 1 plus 2 plus 3. So 6, right? 3 plus 2 plus, yeah, 6. What's the answer given?
Sir, why did you do x plus 1 whole square? So it's fg of 0, product of two functions. Why did you do a composite function?
This is product or this is the composite has been given?
No, sir, product function.
Product, sir, f of g into g of sorry, sir, f of 0 into g of 0. Like this, sir.
If this is a product one, then you'll get x square plus 2x plus 3 and then x plus 1.
Yeah,
Then you
we
should be
get
getting 3. But I guess, okay, so maybe there is an error in however
Yes,
they have wrote. Okay.
they forgot the apply the braces. Yeah.
I guess this is f of g only, but they have to give the bracket, I guess.
Yeah.
Yeah. So that I guess is not been written here. So that's why you're getting incorrect. Anything else from anyone? Any doubt till now? 7 point, I guess 3 we have discussed. So there is nothing much
It's
to
a
discuss
10th
in, yeah,
question.
10th question. Okay. 7.2 only.
Yes, sir.
Okay. So this is like totally based on the sine function. If you are not aware of that sine function, then only you can make a mistake, I guess here. So if you are plotting a sine function, how do you plot? This is what the sine means, right? This is 0, this is pi to pi, okay? And your theta is between 0 to pi by 2. Which of the following option they're asking is true? And what is the doubt? Sine pi plus theta is what? Minus sine, right? And sine I minus theta is theta.
Sir, I have doubt in 7.2 10th question.
7.2, this is 10th question only, right? Or you're asking
This
this
one is
much?
9th question.
Okay, this is 9th. So the 10th is what? Fx has been given as x upon x plus a. This is what you're asking?
Yes, sir.
Okay, and then you have to take the f of f itself. So what is the value of a? So just put the value x and x plus a, and then x upon x plus a equals to what? It has been given something x is 4. And then what do you have to calculate? You have to calculate the value of a. So what is are you getting? X upon x plus a square equals to x upon 3x plus 4. If you're getting cancelled, this one will be left with what? 3x plus 4 equals to a plus 1x plus a square. So I guess a should be equals to 2. So that this will get cancelled and this will also get cancelled. Is it clear?
Yes, sir.
Yeah. Anything else from anyone?
Sir, I have read two statements in the chat from the lecture videos. Could you like explain what does this actually mean?
Okay.
The last one. Yeah.
Yeah, this one, right? There are plenty of sequences that tends to a number. But the function of, okay, let's discuss this first. There are plenty of sequences that tends to a number, okay? If it is a converging function, like sequence that will tends to some particular values, but function of them doesn't tends to a number, as an tends to a and f of an tends to What is this? I didn't get this. What is been written here?
Statement. One was saying that they have plenty of sequences that tend to a number, but a function of them does not tend to a number. This was one statement made in the lecture video. The another was, if as En tends to A and f of En tends to f of A, then this type of function means, supposing that this thing is not true for all kind of functions. That as
Yeah.
En tends to A, then it is not necessary that f of n will all f of En will also tends to f of A.
Is this okay? Which lecture you are talking about? Fourth,
Yeah,
fifth
yeah.
one.
It's last in like last or last second lecture it was there.
Okay.
It was in the conversions series conversion.
Let me see that where it is written. Because from here I'm not. Mhm.
Okay,
Okay.
let me show you the time frame then. Just give me a minute.
Okay. Okay. So okay, yeah. Till the time you tell me the timestamp, I'll just discuss a basic idea about whatever we have discussed about the limit. Okay, so we have basically discussed about the limit of a sequence that can be converging or that can be diverging. So we'll see what does that mean. So let's, for example, if you have some function n, and whenever you are increasing the value of n to infinite, that is getting closer and closer to some particular real number, so real value a. What does that mean? See, if you have a, and whenever you are increasing that to infinite, that sequence itself is going closer and closer to some particular real values a. What does that mean? That is converging, this sequence itself is converging to some particular value, right? This is what it tells. See, let's, for example, you have a sequence somewhat like this. An, your sequence is 1 upon n. Okay. What do you mean by a1? What is a1 here?
1.
1.
1 by 1.
a2 is 1 by 2. And then 1 by 3, 1 by 4. Whenever, and if for this sequence I've started increasing the value till infinite, n starts to putting infinite, what do you get?
0.
What will you get?
0.
Right? So that means
Closer
what, this
to
function, this sequence itself, whenever you started, let's, for example, this was a very big number itself. So this is a very big number. This also will be 1 upon a big number, will start tending to 0, right? And whenever you are
Yeah.
tending, whenever you are starting to increase the value as much as possible, it will start tending to 0 itself, right? So this function is what? This function is basically converging to some particular value 0, right? Correct? So you started with 1, but whenever you started increasing the value of this n towards the infinite, it starts tending to some particular value 0, some exact value 0, right? It will not get the exact value as 0, but it will start tending to 0.
Right.
So there's a difference in that, right? So those type of function we generally say it as a what do you call that, convergent function. Okay, if it's converged to some limit, some real values. So if you have a function a n equals to 1 minus 1 upon n, then is it a converging function? If we just put the values whenever n tends to infinite, will it converge to some particular value, or you are not able to get any particular value?
We will get one. At least
Yeah.
when 1 by n tends to infinity, it will become 0. So it will tend to 1 in this
Yeah,
case.
here, correct. So if you'll see that it will start tending to 0, that means you'll get some random, some exact value. Some exact value has been some real value you'll get, right? If you are,
Right.
if you, for the sequence or whatever you have got, for this sequence, whenever you started increasing the value of the n, you started getting the value of your sequence as 1. Okay, whenever the n tends to infinite, your value, the function values or the sequence value tends to some finite value. So for those type of function sequence, you can call that as a convergent function, right? But if you are not getting anything, let's for example, this is not converging to some random, some fixed value L or some fixed value A. Okay, so then you call that as a divergent function. So divergent function can be like -1 upon n, right? So this will be from -1 to 1. It will just rotate periodically between -1 to 1. You'll not get any fixed value, right? Because whenever you are putting n as infinite, so that will be some number, right? That some big number itself, but that will be some number, right? And that number can be even and odd. Depending on the even and odd, these values will come -1 or 1. That means you are not getting some exact value. You are getting -1 and 1, but that is not exact some particular random value. Is it clear? The divergent one?
Yes.
So if I'm just writing it as like this, n as n, is it a converging or a diverging function?
Divergent.
So
It's a
divergent.
diverging function because you are not getting some fixed value, right? If you are increasing the value of n to infinite, you'll get infinite. But whenever you are changing that value itself, like infinite means what? Whatever the bigger number you can think of, and you just increase that value, the function value, the sequence value will also increase, right? It will not be, it is not going to some particular, some fixed value, real value. Okay, that's why it's a divergent. Okay, if I'm talking about -1, what do you mean by that? Is it a convergent? This is also diverging, right?
Divergent.
Yeah. But there are some other function also that you have to remember. We'll go through that maybe in the next week. How do you get the that itself, like the limit of some different functions? Okay, so see, I'll tell you. So for to calculate the limit, okay, for any different, so till now we were just dealing about the sequence. Okay, for any sequence, okay, that is fine. So let's for example, you have a sequence somewhat like n cube plus n square plus n upon n cube plus 5n. Okay, so this is n. What do you, so if n tends to infinite, so this sequence will tends to what value?
1.
Will tend to 1. And how do you get that?
So just we pull out n cube from numerator and denominator, and then we cancel it.
See, for
And then
that's correct.
apply.
Correct. So for to calculate, to see the limit, okay, to see the limit of any sequence, what you can do is you can individually apply the limit also for each particular. See, for this sequence itself, for this sequence, whatever I have given you. So this can be solved with so many like different methods. Okay, like you can use the
Factorization and all.
Factorization also you can use it, but there is a like, see, whenever you have a the power or the degree of both the numerator and denominator as same, you can directly term it as whatever the coefficient you are getting, that will be the sequence value.
Yes.
Okay.
Yes, sir.
So if you have something like a sequence like n square plus 5n upon n cube, then what do you think? Whether it's a converging or a diverging function, the diverging sequence?
Divergent.
It should
Again
be
converging.
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 It will converge, right? It will converge
to zero.
right?
Yeah.
You can think of, so you can just divide it all the whole function as nq. Okay, you can divide it with
Yeah.
nq. You're left with what? 1 upon n plus
1 upon n.
5 upon n square, right? This will be your function, right? And you can apply
Yeah.
this. This you can think of as a one function, one sequence, and this you can think of as a different sequence. Okay, and if you are calculating, you can just do it like that. N is tending to 0 and 5 upon n square is also tending to 0, right? So that means all together it is tending to 0.
That's right.
Correct?
So one question here.
Yeah.
So what if we are given the an equals to n square minus 5n upon n cube?
Yeah. Okay. So n equals to
N square minus 5n upon n cube.
Then also it will be 0, right? That doesn't matter.
Okay. Okay, because we are separating
Even
this
though
one
you are
as
separating, this will be by
Yeah.
1 minus upon 5 on n. So that also will be 0.
Okay, so algebra of this
So
equals is over
whenever
here.
the
Okay.
sequence like this will be given, okay, you just focus on the maximum degree, okay. So if you are just focusing on the maximum degree, if you are able to see that maximum degree, and you can just pick it out which one is greater and which one is lesser, then you can directly say that. Okay, I'll give you some more questions. It's for so let's for example this sequence. What should be the value for this function?
Converging to 0.
To 0.
Right? It will converge to 0, right?
Yeah.
Yes, sir.
You can directly see that the denominator, if the degree of the denominator function or the sequence is more than the degree of the numerator one, you can directly put it as 0. Okay, so if it was 100 n square plus k and 100 n square plus k2, what should be the value now?
1 converges
It
to
will
1,
tend to
like
1,
100
right?
by 100. Yeah,
correct. So it will be 100 upon 100. So what did I say? Whenever you are getting a sequence like this, you should just be focusing on the coefficient, okay, of the degree. If the first thing you should be focusing on the degree. If the degree of the numerator is higher, you can directly, it will converge to 0, because you already know that for any function, any sequence, 1 upon it will start converging to 0, right? And if you have a function where denominator degree is more than the numerator degree, so denominator degree of denominator is more, okay, than the degree of numerator, you can directly divide that. Whatever the degree, the maximum degree you have, you can divide the whole function itself with the degree of, like the degree of that particular denominator, and in the end you'll get the sequence in the form of 1 upon n or 1 upon n square, something like that. So that means the function, the whole sequence itself is tending to 0. Is this clear to everyone, whatever I have said the last
No,
statement?
like here in this, the degree is same, no, right?
Yeah, for this function, see, I have, let's example 3 example. So you have a function where the coefficient is a1, and then you have a n square upon a2 n square. Okay, so here it will start tending to a1 upon a2, correct? Whenever you have an square plus some k1 and then a1 n cube plus k2, so here it will tend to 0.
0.
Whenever you have a1 n cube upon a1 n square,
Yeah,
will it
so,
converge?
so for the first
No,
case,
that would
it
be
it
divergent.
depends on A1 and A2, right?
Yeah, the coefficient, correct.
Yeah, we cannot specifically say that it will converge or diverge to 1 only or anything
Yeah,
such.
not
Yeah,
1
that
only.
depends, because here we were having 100 upon 100, right? So that's
Yeah.
why we told directly.
Yeah.
How I
Correct?
didn't get that.
Okay, so here, what did I say? If you are having a sequence where the degree for numerator and denominator both are same, you can just directly divide it a1 upon a2. So see, I'll just give you one example. a1 n to the square plus a2 n upon a3 n square plus a4. Okay, this is the question that has been given to you as a sequence. Okay, so what will you do? First of all, if you have been given this type of sequence, and the sequence, you have to calculate whether it's a converging, and if it is converging, at which particular point it is converging. So what will you do? You'll just divide. The first step is you can just directly divide n square with all the values. Okay, so if you are dividing the n square with each and every values, you will be left with what? a1 upon a2 upon n, and then a3 plus a4 upon n square, correct? And you already know that if you have to calculate the limit, you can use directly. You can go to each what do you call that, sequence, and if you will see that this a 1 upon n, we already know that 1 upon n directly converges to 0, right? So a2, so for any constant k upon n, that will also converge to 0, correct?
If
Yes,
we are
sir.
talking, if the function is an, then yes, yeah, it can. Yeah.
And this also will converge to 0, right? So you are left with what, a1 upon a3 itself, correct?
Yeah.
Yeah, so this should be the value, and if you have a1 and a3 both are same, then it will converge to 1,
Okay. Got it.
correct? But yeah, the other thing is, if you have the denominator, the degree of denominator is more, then you can directly say that it will converge to 0, because you already know that for any function in the form of 1 upon n, it will converge to 0. Okay, so that's why it will converge to 0. Is it clear to everyone? Is it clear or not?
Yes,
Yes,
sir.
sir.
Okay. And this is all, and how, and all these things, how, like like for example, we were able to separate all those functions, right? So for example, here we got some function, this type of function, we were able to separate it, right? We can write it an and bn. So there are some particular characteristic also for the limit. Okay, so let's, for example, you have an as a sequence, and for this an you are getting a as a converging value, and if you have bn as a different sequence, and for this bn you are getting b as a converging value, right? So for any function an plus bn, so the it will converge to a plus b. This is how, this is why we were able to use all this stuff, right? All these things we were able to use because we already know that for for any sequence an equals to 1 upon n, and any sequence bn equals to 5 upon n square, we already know that if an is tending to some value a and bn is tending to some value b, we can directly calculate. If you have been given to calculate the limit of an plus bn, you can directly add this a plus b. This is what we were using it here also. We just pulled out, like we just separate the two different limit sequence, and then we can see that this can become your one sequence and this can become your second sequence. And if you are able to calculate the limit of both the sequence, you can directly use the arithmetic. Okay, so for any function for any sequence an, if you are able to convert, if you are able to get the value, the converging value as a, and for any function bn in sequence bn, if you are able to get the converging value as bn, you can use this all arithmetic. If you have been asked to calculate the limit for an plus bn, you can directly write it as a plus b. For any function c multiplication, c is some constant, times the an, you can directly write it as c into a. Okay, because an, you already know that an is converging to a, so the converging value of c into the sequence an will be c into a, right? Similarly, you can write it as an minus bn as will converge to a minus b. Is this clear to everyone? The different rules that we have discussed about the converging of the sequence.
Yeah, clear.
This simple, right? So you don't have to, like, if you have 2, 3, n number of sequence, if each individual sequence is converging to some value, you can use directly the arithmetic. Okay, so no problem in that. Even though if you have a sequence an and you have been asked an and bn, and you have been asked the sequence for an and bn, you can directly multiply a into b also. Is it clear? Similarly,
Yes, sir.
for an upon
Yes,
bn
sir.
also, you can directly get it as a upon b.
Yeah.
So this is what we were using it here. All the things, whatever we have discussed, we have used all these rules. So for any function, for any, so this is the one rule, right? So we were discussing about any given sequence cn, and that was an a1 n square plus a2 n upon a3 nq plus a4, correct? So we were using this all the arithmetic only. So you can directly divide, you can think of this as a one sequence and this as a different sequence, right? So this has some sequence number 1 and this has a sequence number 2, and in this sequence itself, an n square plus a2 n, you can think of it as a sequence summation of two different sequence also, A3 or A4. So you can, what I mean to say is, for if you have to calculate the limit of a sequence, you can directly use the arithmetic. You can directly apply the sequence at each particular sequence itself, and that sequence can, so the original whatever you have been given, a different like a sequence that has been given to you is a complex of some n number, like 2-3 different sequences, okay, A1, A2, A3, A4. So you can directly go to the individual sequence that can be a subsequence of any different sequence, and you can directly apply all your concept on that particular sub part, and then if whatever you're getting, and you can use the and in the end you can use the arithmetic, all the arithmetic that you generally use for the mathematics. So all this will hold here for the whenever you have to calculate the limit of any sequence, okay. So that is how we were able to calculate the sequence of this all different functions that we have discussed it here, because we were able to use the arithmetic, okay, rules to calculate the convergence, to calculate the convergence of any sequences. Is this clear to everyone?
Yes.
Yeah, and this is how you calculate for a function. So this was for the sequence, okay, for some particular sequence you have been given, and that can be changed to the that we can upgrade it to the functions also. So you can calculate, you can be given to calculate the limit of any different types of function itself, like, and basically see, if you have been calculate the limit can be from two direction, okay. So there can be a function, so limit, whenever you are discussing about the limit, so basically limit means you are coming from both the directions. See, if you have been given a function like this, and if you have been asked to calculate the limit at some particular point A, okay, so what you have to do is you have to come from this side and this side, okay. So A minus and A plus. A minus generally represents that you are coming from the left direction, and then whenever you are tending from coming from the left direction, whenever you are tending to the value A, what is the function value at that particular point? So what is the Fi? Okay, and when you are coming from the right hand side, from A plus means you are coming from the right hand side to A. So whenever you are coming from the right hand side and your values is tending to A, then what is the value of the function at that particular point? Correct? Is this clear to everyone? So to calculate the limit of any function, so you have to come from the left and right hand side both, okay. So from, if you have been asked to calculate the limit A minus, that means you have to come from the left hand side, and then whenever the A minus is tending to A, what is the function value? So basically you have to calculate Fa minus, correct. And whenever you are coming from the right hand side A plus, that means you are coming from the right hand side, you have to calculate the limit from the right hand side, okay. Both can be same. If both are same, that means the limit exists, okay.
Yeah. Yes.
And more we'll discuss about that continuity, how does that help us in the continuity, differentiability, and all those other stuffs we'll discuss. But till now, we just should be knowing about how to calculate the sequence, how to calculate the limit of a sequence, whether it's a converging, diverging, those things you should be clear. And you will be asked in the quiz also this type of questions, okay. Different types of functions can be, sequence can be given to you. And for to calculate the limit of a function, the best method is, do not get confused, you can directly use the L'Hospital route, okay. Any most of the time you will be able to use, and whenever you will be asked, till now whatever we have discussed, you can directly use the L'Hospital. In most of the cases you will be able to use the L'Hospital. L'Hospital is pretty simple concept. So if you know the concept of the differentiation, I guess most of you would be knowing. If not, I guess in the next lecture, next week, the differentiation concept will also be discussed. But if you know that, you can directly calculate the limit for any different function of the form of n upon ax or upon bx. You can directly calculate the limit for all those different functions. You just have to differentiate it, both the function up and down. You have to differentiate it till the time, let's for example, you are okay, I'll just give it, try to explain with some examples to how do you calculate the limit. There are different methods to calculate. You can use the sandwich method also, sandwich theorem also, but that's the, like, I'll suggest you, if you know the differentiation, go with the L'Hospital method each time to calculate the limit, okay. The only things that you should be knowing to calculate the L'Hospital, to calculate the limit for any function using the L'Hospital is L'Hopital rule, generally you call that. I like, it's like the pronunciation is a bit difficult, so from the childhood we used to call that L-hospital. So it's like this is what we call. I'll just explain you how do you calculate using that method to calculate the limit of any functions. So let's discuss some of the questions. How do you calculate the limit? First of all, you can use the other method also. That's like totally fine. If you're comfortable with the other method to calculate the limit, you can use those method also. But I'll prefer you to go with this method, and most of the time you'll be able to use it. Okay, it's like most of the time whenever you'll be given, because it's like a basic course, so you'll be given mostly the 0 upon 0, infinite upon infinite type of the limits. So in those cases you'll be able to directly use this method to calculate the limit. Is this clear to everyone till now? Whatever we have discussed, the sequence, the limit of a sequence, is this clear to you?
Yes. So one question here.
Yeah, go ahead.
Sir, so what can we say about the convergence and divergence if we have the limit of that sequence? Like if we able to calculate the limit of that sequence, so can we infer any information about the convergence or divergence?
See, if you are able to limit the function itself, that means you are able to get you already know that it's converging, right, to some particular value.
Yeah.
So
So
convergence and
what about
divergence,
the
you calculate it.
divergence?
Okay, convergence and divergence, you just basically calculate for some type of a sequence, right? How does that sequence behave, right?
Yeah.
So that segment, let's for example, you have a sequence A, okay, and it is converging to some particular value A, right? That means what? It is converging, right? And if you are not able to, for the sequence A, you are not getting any A or any real values, some random values.
Yeah.
Okay, that means what? It is a diverging function.
Yeah. So
diverging
if
sequence.
yes. So if our sequence n converges to A, that means the limit, if we take n tends to infinity. Yeah, and here we take the infinity. So the limit of that sequence would be the A.
The limit is limit, or you can say, yeah. So for that sequence itself is A, because it is limiting to A. The values getting closer, converging to A. So there's so many other methods to say that, but okay, it's fine if you are so pretty simple. Like you can say it like whenever you have a sequence A, and whenever this sequence directly is converging to A, that means n is tending to infinite. And if your values, if you are thinking n as very large, okay, the function or the sequence is tending to A, the function's value or the functions, it started getting closer and closer to A. This is what you directly say it as.
Yeah. So that means the limit, like converging or diverging, is the special case, like a particular case for the limiting, like when we can taking the n to the infinity, then we get the convergence.
See,
So,
this is what we have discussed.
Yes. So
So
we
limit-
cannot say anything about the divergence sequences.
Divergence, you can't say like the exact value where it is diverging. I told you, right? There is a function, a sequence a to n minus 1 to the power n. So you can't say that where it is going, because whenever we'll change the value of n, the values you are getting is a different from value, right?
Yeah.
But if you have getting a sequence like 1 upon n, that you already know that whenever I'll start increasing the value, this function will start going to 0, right? That means it is converging towards 0.
So, like, if you can specify, what do you mean when you say a sequence? It's a series progression or what?
Some type of a series value itself.
So for calculus, we need to study progression and harmonic progression and also.
No, you don't have to.
But it forms a base for calculus, right?
But okay, see, GP, HP and all, it's not going to help you. Like you just should be knowing that this is a sequence, some type of sequence like 1 upon n. Okay, this is a sequence. Okay, that can be any sequence. There can be n number of sequences. It's not like only a GP
So
or AP or.
you mean that like we can without those HPs and progressions we can go with calculus.
Correct.
Okay.
That's why it's not been taught here, because you can handle it without knowing all those things also.
Okay.
So I have shared the time frame link with the of the video with the time frame in the chat.
Okay.
I guess
So
the question will be framed in such a way that we want to use this, the progression and all.
yeah, so the progression, so you'll not be getting any problem where specifically
Yes.
you'll be using those progression or any type of sequence, particular sequence. Okay, you'll be
Mhm.
getting some simple or maybe a complex sequence also, but that will not be anything related to fixed sequence like GP or AP or anything HP. Okay, that will be some random sequence, and for those cases you will have to know whether the sequence is converging or diverging. So there are, I told you some methods how to get and closer and closer, how to get the values for the converging values of any sector. Okay, so there I don't think so you'll be using any concept of any formulas for regarding geometric progression or harmonic or any arithmetic things. Okay,
Okay.
yeah. So you don't have to worry about those things. You'll be getting any sequence that will be totally like unrelated to the AP or GP. Like if somebody knows also, I don't think so he'll be able to use any concept in those type of problems. Okay, let's so yeah, so I guess no, Ankit there, right? You only said or
Yes, sir. Yeah, it starts from here.
here what has been written. I don't,
So it's the last YouTube link itself.
Let's check it. This what it's asking. So I guess are you asking about this statement if there is any real number L such that FL is tending for all sequence N such that this is what you are asking?
This point, yeah, but means this 2-3 statements at this time frame, I'm not able to exactly grasp means what sir is like saying here.
Just saying that see this is the statement, right? If there is some real number L, okay, and let's for example if an is tending to L, okay, if an is tending to L means what? Whenever see you are having a sequence an, correct? Let's for example this is a function, this is a function for you, and then let's for example this is an, okay, and if an for all the sequence, if there is a real number L such that a f an, so this is an for you, an is tending to L value, so this is L. It's not the exact value, but it is tending to L for all the sequence an. So that's you see this an function, this an sequence is tending to some values a. Okay, that means it is converging to a. So you were having a sequence an, okay, and it is converging to a from the left hand side. Okay, that means this an is tending to a, some real values a, correct? Every time whatever you are taking, this an will always be, see, what did I say? For any sequence an, that's for example 1 minus 1 upon n, correct? But this is coming from right hand
Yeah.
side. An, yeah, so 1 minus 1 upon a. Okay, this is converging toward a, right?
Okay.
A means
So
1, you
for a
can say
particular
that.
value, we will
This is converging. So for
Mhm.
any sequence an, that is converging toward a from the left hand side, right? And always an is less than 1, correct? So for this sequence an, it will always be less than 1, but it converging toward a, correct?
Just give me a second. It's going to be, yeah, it's going to be less than 1.
Okay. So and at this particular point, if a, you'll be getting some, like this function will also start to this function will always tends to L. See, basically this whole statement is what saying that from the left hand side, if you have been you have been given any function, okay, and if you have to calculate the limit from the left hand side, this is what it's saying. Okay, this whole thing, whatever is given, if it is confusing you, this simply says that you have a function, you have some sequence, and that sequence is limiting to some value a, okay, and that is coming from the left hand side because you it's been given that an is always less than a, so it is coming from the left hand side, and you have to calculate the limit at that particular point. So that means if it is coming from the left hand side, that means you'll be able to calculate the left hand limit for that particular point.
Okay, means it's just saying that if we are moving x input to a particular value, then our function that is output is also moving closer to certain value.
Certain value L, yeah.
Okay, but so what does it means here that it's
It just simply means that your function, if this function, right, your left hand limit exists, this is what it's saying. So if you have a as a value, okay, and if you are coming from the left hand side, okay, and if whenever you are coming from the left hand side, that means a minus, and if a minus is, if whenever the sequence is tending toward a, okay, your function value is tending toward L, okay, and if you are able to get that value, that means what, the limit exists, the left hand limit exists for that function. This is what
so
it's saying.
could you like give your example in which when we are putting this an closer to a, but f of function is not coming closer to L from a
So there
single.
can not coming closer to a, so then the limit doesn't exist for those cases.
So just a plot will do. It will help me understand it better.
See,
Which
if you are not able, if you are coming from left hand side, okay, and if your value, your sequence is tending toward a, but if a is not tending toward some value L, that means the function, the left hand limit doesn't exist. It's pretty simple. See, if you are coming from left hand side, if your a, the value sequence, see, limit means what, at that particular point, if you are coming from left hand side or right hand side, if both the values are equal, you can directly say that the limit exists for that function, correct or not?
yes,
Is this
yes,
clear?
yeah.
Okay, so if you are coming from left hand side, and if you are not able to get some particular values itself, then you can, what you can say is, the limit doesn't exist, right, at that like, see, if there is no such value L, then what you can say is, you can directly say that the limit of a function at L or a from the left hand side doesn't exist. That means the limit a minus doesn't exist.
Yeah, but that's fine. But I would like to have a. It's possible if you could share an example, like graphical or something, so that it
Okay,
it will have a visual perspective for me also.
okay, let me think of some example and see. And okay, so I'll give you one example. One thing is from, so right hand side you're clear, right? So if the same thing, if a n should always be greater than a, okay, and if it's coming from the right hand side, and then also if you are getting, if the function value is tending to L, you can directly say that it is a the function is the limit exists from the right hand side,
Yes, sir.
okay, and if both are same, then you can directly say that the limit exists, correct?
Yes, sir.
Okay, so mm-mm. Okay, can you say that for this function, whether the limit exists or not, if you're coming from the left hand side and right hand side, is both same value you're getting?
Yeah, they tends to be give the same value.
That tends to be the same value, right? So that
Yes.
means what, at this
Where
particular point a, so whatever the sequence you were having, doesn't matter. So that you should not be thinking. So whenever the function, whenever your x is tending toward a, okay, whether it's coming from a minus or a plus, that doesn't matter. Your function value is what? 0.
Yeah.
Correct?
Yeah.
So that means what? The limit exists for left hand side also and right hand side also, and both are equal. That means the limit exists at that particular point.
Yes, sir.
Correct? Yeah. So this is what you call that.
Sir, I was asking for example in which when we are moving closer, inputs moving closer to a certain value, but output, that is function, is not moving closer to a certain value. I was asking for that example.
Okay. 1 second.
Because I tried to think, but I was not able to grasp like how this function should be look like, or what type of function they are.
Okay. Let me go through some example itself of the activity question. Am I able to find it or not?
So in that way, that will not be continuous, right? It will be breaking in between.
That will be breaking somewhere, some point, at some particular point.
Yeah.
See, if we have a function, but again you will say that okay, so let's, for example, there is a function.
And draw any function.
Okay, and then it's somewhat like this. Let's, for example, this is 2. The limit doesn't exist, that is clear, right? But the problem is, if you're coming from the 2 minus and 2 plus, both are having a different value. That's why the limit doesn't exist. But you are asking to give me an example where the 2 minus itself doesn't going anywhere.
Yes, sir, because that was the statement that brought a confusion to me. That
okay, so let's, for example, this is a function, this is going to infinite, okay, and this is also going to infinite. But here the limit exists because it's tending toward infinite, right?
Yeah.
For any particular point -9, it is tending to an infinite. From if you are coming from left hand side or right hand side, you are getting some values, and that is infinite basically. So limit exists for this case. But here the limit doesn't exist because you are getting a different values. But I'm not able to think of any example where the value itself is not, you are not getting any values itself. Okay, I'll think upon that. Okay, I'll have to think upon that where you're not able to. Maybe that can be some diverging type of stuffs where the function itself is not going anywhere. Because here you can get some type of example where limit doesn't exist, but at least you'll be having some left hand and right hand values at least. Correct.
Yes, sir. That's easy to get, like, because it's moving in certain direction. So if I have direction, we can predict that where in that next instance it's going to be.
Yeah, because see, that's the like type of chicken and egg. Say if you're just thinking of, because we have assumed that this is coming from the left hand side. Okay, we have already assumed that there's a sequence, and that sequence is already converging to some particular value. That means that function will give you some, for sure, some values, right? See,
yeah,
an was converging toward an. If an was not converging itself, then you'll not get anything, right? Correct or not?
Yeah.
See, what was the definition? What was the statement? The statement was, see, a, you are getting an tends to n only if a is tending towards some value a, correct?
Yeah.
That sequence was converging towards some a, then only you will able to a, because there is a function, and if you have a function, that means you'll get something, right? If you are putting some x value, you'll get something, correct?
Yeah.
Yeah. So we are already assuming that an is converging toward a. If an is converging toward a, that means what? You'll get something out of that. If you are converging, an is converging toward a, that means whenever you're putting that a into the function, you'll get something, and that something is matching to the right hand side or not, that that will tell you whether the limit exists or not. But if you're just talking about the left hand side itself, while putting for a given sequence converging towards some particular value, that value is going to give some random value L. And if we are getting that L, that means you can directly say that the limit of the left hand side exists. Correct? But is this clear? Is this making any sense or not?
So this, but if we are moving our input, then we can say that its function, though its output will exist, that is function value will exist. So it will certainly go towards some value, some particular value. That's clear.
Even though if you will take the example of a floor function also, the floor function basically, if you're coming from left hand side or right hand side, you'll get some two different values. That also is there. Even let's for example, you're taking a function, okay, that also will not work because you'll always get some values. You are getting some values. That is it. That is totally irrelevant that you are getting a two different values because the example is not setting up like. Okay, I'll think upon this. Okay, and maybe in the next session I'll discuss that. Okay.
Okay, so I'm sharing like the complete sentence that sir said in the lecture in the chat.
I got that. It's just
Okay.
saying that whenever you have to define a left hand limit, it's basically that for any sequence n that is tending toward a and toward a, so you are getting some function value L. If you are getting some function value as L, that means a limit L exists. Limit at that particular point a exists. And if you're not able to get L, that means the limit doesn't exist from the left hand side. This is what the statement is, right?
Yeah, but sir, in the verbal thing, sir said that sequence do not tend to have for that number.
What sequence do not?
Sequence do not tend to that particular number. Just a second. Let me open it. It's saying that there are plenty of sequences which tend to a particular number. And then it is saying, but a function of those sequences do not tend to f of that number.
Function. Okay, I'll have to. I didn't get you. Okay, so
Sir,
the
share
whole
the chat.
statement.
Please
If I see the whole statement, then I'll be able to comment on that.
Sir, I've shared in the chat the screenshot of the same. Please, we can discuss it in the next class. I will also give it a thought, like what this particular function means what kind of function sir is talking about. We can discuss in the next class. Please just save this.
Okay, I'll just see that what is that statement. You're saying the same thing, I guess, again.
Yeah, this created a doubt for me. Like we are not certainly like I was not able to relate that limit concept. I'm clear now, but what this particular statement is, that's a bit foggy for me now.
Okay, I'll just go through the statement. I'll just go through that statement. What does that is written or what their professor saying? Okay.
So for that statement which you wrote above, your example is correct, I guess.
Yeah, that's
Yeah,
example. No, what
this
he's
example.
asking is, I guess he's asking, like if you are, so there is some sequence, and then there's some sequence, okay, and that let's for example, there's a sequence that A and that is tending toward A. Okay, from the left hand side or any one direction only. If it's coming from one direction itself, and then you are not getting any value L.
Yeah,
Can you have an example?
Yeah, this example from left hand side we don't have anything.
For which example?
Yeah, for this one, the one which is below the which you have written AN tending towards A. This one which is discontinuous.
Yeah. So no, for this we have this value, right?
Which one?
This value.
No,
This
but
value, let's for
but
example, this is
at
6. No, for the limit now, we don't discuss like the exact value at that particular point. So the neighboring value we deal with. So even though, let's for example, so for this function the limit doesn't exist. Okay, why it doesn't exist? Because the concept is, see, for left hand limit we are getting, let's for example, this is 6 and this is 2. So here the limit doesn't exist because we are getting f of 2 minus as 6, and f, and this is tending to, and f of 2 plus has some different value that is tending to 2. That's why the limit doesn't exist. It doesn't, if you have been just asked to calculate the left hand limit 2 minus, you'll calculate it as 6, not as not defined, because you're getting something closer to that value.
So what's the question?
Yeah, its question is, can you give me an example that you are tending toward 2, but you're not getting any value at that particular point?
No, we will get a certain value. That's why the function is defined. Or any
This is
polynomial
what,
given.
correct. This is what I also thought.
There is
but
no place where we do not get anything.
if that is in the domain, if that is not
Yeah.
in the domain, you will not get anything.
Yeah, obviously. Yeah.
But I'll just check the statement. I'll just check the statement. What is that statement? Okay. But maybe if there is something that I have to say, I'll just come up on that. Otherwise, whatever the limit, as per I have been knowing, it's like simple. It's not complex. Nothing complex in that to calculate the limit or to how to define the limits and all. I'll just check the statement. Whatever he's pointing out to, I'll just go through that. Okay, so I'll just give you one example more. For any function, how do you calculate the limits and all? So let's, for example, this is a function has been given to you, where it's going somewhat again like this, and then it's going like this. Here again, this is again, here it is open. This is also open, and this is closed. Just for example, this is 2, and this is 5. Okay, let's for example, this value that you are getting is 3. This value is 4. So can you tell me whether the limit exists for 2 or not at 2? Okay, first tell me what is 2 minus, f of 2 minus.
F of
What is
2
f of 2?
4.
2 minus is what?
4.
4.
And 2 plus is 3.
3. Okay, what about the 5 of this goes like this. Okay, f of
5, like limit it's negative from negative side, it's like 5.
okay, 5
It
minus.
doesn't exist, sir.
No, sir is talking about the limits. So it's not talking about the exact value. And plus 5, it's like 4, but functional value is 5. Functional value is 3 at 5.
Yeah, so the f of 5 plus is again some different
4.
values. F minus is, let's for example, this is some 8. So this is 8.
4.
F of f plus is 4.
4.
But the exact value, f5, the exact value is what?
3.
Doesn't exist. Okay.
No.
Yeah, limit doesn't exist. That is clear because all the 3 different. But f5, I'm just asking. F5, what is the exact value at 5? The 3, right?
Yes, it's 3.
And the limit doesn't exist because you can see that the left hand and the right hand limits are not equal.
Yeah, so what is the question?
So, I just thought like after going through this example that you just said, so you're saying that if like just a second, it's saying that there are plenty of sequences which tend to a particular number. Means if it's same as saying that as we are moving, say from left hand side from this up to like 2, okay, that is x is moving closer to 2 from the left hand side, then f of the sequence do not tend to f of that number. F of that number means functional value itself, that you are saying that f of 2, what's the value of f of 2? Means if I am saying that f of 1.9999, that's certainly going to be 4, but f of that is certainly not close to what f of 2 is. Means he's talking about discontinuity only, I think.
I can. So okay. So see, I don't know why we are making it complex, but okay. So for this function, so at 2, you can directly say that the limit doesn't exist because both the values you are getting is a different, right?
Yes, sir.
Right. So see, there can be a number of points, like there can be some 4 or 5 conditions where the limit doesn't exist. Okay. So the one condition can be what?
Break, when there is a break in the graph.
So the one condition can be there is a break in a graph, right? There is a graph like this, and then this is coming like this. Okay. So this L and M is not equal. So L is not equals to M. That means whenever you're coming from the right hand side and left hand side, if the both are not equal, you can directly say that it's not, the limit doesn't exist. I don't know the other methods. So what the only, and then the other things can be what? A function can be like this, right? This function, okay, at A, if you're going from the right hand side and left hand side, both are not equal here also, correct? But the
Yes.
limit exists for both the cases, left hand and right hand case, both. But both are not equal, so that's why you can directly say that for the limit of A doesn't exist, correct?
Yeah, but first and second case both have the similarity that right hand and left hand limit are not equal.
Here also, the left hand and the right hand limits are not equal. Directly,
Yeah.
you can say that the limit doesn't exist.
Yes, sir.
Okay, so I'll just give you some more examples about the limit. Okay.
So, but what will be the value at that point? Will any value will exist? Just like F5, what you were saying, sir?
For this case,
No, the previous example. Can you scroll up?
this,
What will be F of 5? How the 3 is coming?
which question? This.
No, just scroll up, sir, which is showing above. F of 5 equal to 3.
Because the
we
f of
reached to
5
that?
was been given. F of 5 was given as 3 only, right?
Oh, it was given? Okay, sorry, then I
Yeah,
missed
it was
it.
given already. Yeah.
So, are there more cases where this function limit does not exist beside these two?
No, there can be. There can be. There can be more places also where the limit doesn't exist. See, if you are given sine, okay, sine 1/1. Okay, so let's not discuss this. I guess this has not been discussed. At least 2 conditions we have discussed. There are conditions that I guess is not been discussed whenever you are having something like this. But again, this has not been discussed, so I am not. So let's, for example, this function like this. Okay, for this type of function also, the limit doesn't exist. Like there are other functions also I can, but as we haven't discussed like this function, or there can be a functions which is going like this, which is tending to minus infinite, or whenever you are coming from left hand side also, right hand side also, but the exact value you are not knowing. So those type of function also the limit doesn't exist for those cases. But okay, so we'll not discuss those functions. There are generally 5 conditions. 2 conditions I have already discussed, that I guess is been discussed in the lectures also, but the other 3 cases not been discussed, so that's why I'm not discussing those cases.
Okay.
Okay.
Could you also discuss the standard limits like sine of x by x, y is tending to some constant, and there were like 500-600 standard limits that were given. So do we need to dive into like why is it so? Why are these limits so, or should we just remember them?
So you can just remember that for some function I can then directly tell you what are the function that has been discussed. Let me just open that, which are the function that has been discussed in the lectures. Because mostly, because there can be n number of functions, right? So but if you have been discussed about only some functions, it's fine. Let's, for example, what are the function? The first function that has been discussed to you is, see, I'll
Sine.
just start with the basic one. Okay, let's first we'll just discuss function. The first example, you have to calculate the limit. Okay, and let's, for example, the limit x tends to 0, not 0, x tends to 2, and the function given is x square plus 4x plus 1 upon x minus 2. Okay, what should be the value? What will be the limit for this function?
Undefined or infinity.
See, one thing, the limit you are not, whenever you are calculating the limit, you are first of all taking care of the neighboring value. Okay, how does that function, what's the value of the function neighboring to the 2, not the exact value. Okay, so that should be there in your mind. Okay, always you can't directly put it 2 here, you can put it 2 for the other cases. Okay, wherever you are not getting that some constant amount 0, but for this case you can't directly say that the function value, the limit doesn't exist. You can get some other thing like, see, okay, I'll just simplify this case. This case is x square minus 5x plus 6, where you can factorize it. Can you tell me what should be the value, the limit value for this case? Can you factorize it like x minus 2 and x minus 3?
Yeah.
Okay, so now what are you getting? X minus 3. So what is the function value that you are getting, the limit you are getting?
Minus 1.
2 minus, now you can put it directly. Okay, okay, there are other methods also. See, let's, for example, this was the same case, x square minus 5x plus 6 upon x minus 2. This was a function when given to you. See, whenever you are getting this type of problem where you are getting like 2 square, like some constant upon 0, right? What you can do is, you can start differentiating the numerator and denominator both. Okay, if you are just differentiating the numerator itself, what are the you'll get? If you are differentiating the numerator, what are the value you'll be getting?
2x minus 1.
minus 1.
And what is the, you'll be getting the denominator?
X.
1, right?
Yeah, 1. Yeah, 1.
Okay, can you put it the value 2 now?
Yeah.
Yeah.
So what will the value you'll be getting? 2 into 2 minus 5 upon 1. So this is minus 1. So this is your limit, correct? The limiting value at for the function at whenever you are tending to 2. Correct?
Okay, so
Yeah.
this we can always do, like differentiate numerator and denominator.
See,
And then
not always, but whenever, most of the cases, most of the function that you are dealing with, you can use it, this L'Hospital always. Okay, or L'Hopital's rule that you call it as. You can use this method. See, for
what's the
sin x,
condition for this?
yeah,
Like,
yeah.
what's the condition for using this method? Like,
The condition is okay. So see that there are some condition, 5, 6 condition where you are using, but I am not going into that. See, I'll just tell you whenever you are getting zero, okay, 0/0 form or some type of infinite upon infinite form. Okay, those cases you can use it. Okay, at least I'm just telling you this much. There are some other cases also, but that you don't have to go into. Okay, there are some other cases also, but see why I'm saying that this method you can use it directly here, because whatever the function we'll be discussing, most of the time it will be, most like 99.9 times it will be in the form of some 0/0 infinite upon infinite. So you can use it directly. Okay.
Okay, sir.
Yeah. See, for example, sin x upon x, whenever the function is x tends to 0, in which form this is, sin x is, sin 0 is what? 0, right? 0/0. Can you use the method? Yes, right? What is the differentiation of sin x?
Cos x.
Cos x.
Cos
What is the differentiation of x?
1.
1.
1.
What do you mean by cos 0? 1, correct? So
Yeah.
the limit of sin x upon x is 1, correct?
Mhm.
Yeah.
So you can use it every time whenever you want. Like, let's for example, you have a limit a to the power x upon b, and then you have c either x plus d. Okay, what should be the value you'll be getting here? So you can directly put the value x equals to 0, right? If you are putting the value 0,
A
you will
plus
directly
B
get
upon
it.
A, C plus D.
Correct. A plus
It will be
A
A
plus
plus
B.
no, yeah, a plus b and then c plus d.
C plus
Correct.
D. Yeah.
You can directly get it right. See, and if in the same example, if it was given L tends to infinite, x tends to infinite, then what should be the value?
A by C.
A by C. Yeah.
A by c. How did we get that?
I divided numerator and denominator by e to the
Okay,
power.
that is fine. And you can differentiate for this case again, infinite by infinite you are getting, correct? If you'll put
Yeah.
infinite directly here, you'll getting infinite in the numerator, and the denominator also you'll get the infinite. So we can use our method, L'Hopital's rule. You can differentiate it. If you are differentiating, what you will get? A to the e to the power x, correct?
Yeah.
And again, if you are getting c, e to the power x. But the problem here is you'll get e to the power infinite again and again whenever you are differentiating. Okay, it's better to use directly this method. See, e to the power x, what's the problem with e to the power x? Whenever you're differentiating e to the power x, every time you'll be getting the same value, correct?
Yeah.
Yes.
Okay, and if you are differentiating, this will get cancelled, so you'll be left with a upon c.
Yeah, that.
Okay, so there are other methods also. You can use it every time, even though you can use most of the time you can use this method. Okay, I'll just give you some more example if I have anything. See, tan x upon x. X tends to infinite. Tan, what is the tan 0?
0.
not defined.
Tan 0 is 0.
No, sin 0 is 0 and cos 0 is 1. Sin 0 by 1.
0 by 1. 0.
0.
It will.
Okay, yeah, 0.
So this is 0 by 0, right? So 0 by 0, can you use our method? You can use that, right?
We can differentiate it.
You can differentiate. What is the differentiation of tan x?
Sec square x.
And what the differentiation of sec square x upon 1? What is sec x at 0? 1. You'll
1.
get 1.
Yeah.
This you can solve with the other method also, like you can directly write it as sin x upon x into 1 upon cos x. Correct? So cos x, see, you already know that if you have a limit, you can directly separate these functions also. This you can term it as one function, this you can term it as a different function. Okay, so for this function 1 upon cos x, whenever you'll put x tends to 0, this will be 1. Correct? And you already know that sin x upon x, you are getting 1. So 1 into 1, so you are getting 1 as a limit. So you can use any method to calculate the limit. Are you able to understand this?
Yes, sir. This method is like quite uh good to separate this term, multiplication term itself, like decomposing it in the form of multiplication.
Yeah, you can use it like, see, for example, 1 minus cos x upon x square. Limit x tends to 0. Whenever you are putting the value 0 here, what are you getting? You are getting 1 minus 1 upon 0. That means 0 upon 0 form. You can use the method. So whenever you are differentiating, what is the value you will be getting? This will be 1 will be 0 minus cos x ka differentiation. What do you get? Minus of sin x, right?
Yeah.
And then you are getting 2x. So again, so see, you are getting what? Sin x upon 2x. Again, if you are putting 0, you are getting what? 0 upon 0. That means you can use the method again. And now you can differentiate it. Whenever you will differentiate sin x, you will get cos x. And whenever you are differentiating 2x, you will get 2. Correct? And now you can put the value of x as 0 here. So 1 upon 2 should be the answer. Is it clear?
So we will do this until we get
Yeah, until you are not able to exclude that 0 upon 0 or infinite upon infinite form. Okay?
So is there any method to
Is
do it
there
in
any
once at once?
At once you can't do that. You can do that at once. Without this method, you can use that. Let's, for example, this is a method, right? 1 minus cos x upon x square. Okay, this was the question. What you can do is you can write. Do you know 1 minus? What do you mean? Cos x. This is basically 2 sine square x by 2. Okay, if you know that, you can directly use that here. 1 minus cos x, you can use this directly. So 2 sine square x by 2 upon x square. You can write it like this, right? 2 of x ka whole square, and then you can multiply it as 1 upon 4. So now you are left with sine of x by 2 ka whole square upon 4, and this will be 1. So you are left with 1 upon 2.
Yeah, for this
That's
like
sine square.
trigonometry is.
So that's sine square x plus cos square x equals 1 now.
Oh, no. See, this is a different thing. See, this is so basically, I'm not writing, see, 1 minus cos x, you can use it directly to sine square x by 2.
Okay.
Yeah. This basically comes from like cos square x sine square x plus cos square x equals to 1 only. But yeah, here you'll be using the half wala method, like half a formula also. If you're not knowing, you can use this method directly. You can differentiate it. So at least see, for to calculate the limit now for the exam also, at least some 5 or 10 differentiation thing you should be knowing about, at least for this all the 6 tan, and at least not all the 6, but at least sine, cos, tan you should be knowing. Some differentiation of log you should be knowing. Exponential function, e to the power x, all those functions you should be knowing. If you are able to know this, the differentiation of this important functions, will be able to solve at least the limit thing. So you don't have to use every time other methods, like what should be the, if you have been given some trigonometric, if you are not aware of this, for example, I guess if you haven't read this trigonometry, and like maybe if one revised it recently, you'll not be able to know this. Okay, so it's better to solve with this method. L'Hopital's rule, you can use it every time. Like, you just have to check whether it's in the form 0 upon 0 or infinite upon infinite. And if it is in the form of that, you can directly use that method. For that, you just would be knowing the differentiation of some 10 standard equation. That is more than enough to solve any questions.
So
Okay.
there was one more like limit discussed in the lecture, that was ln of 1 plus x divided by x, and x tends to 0.
What is that? 1 upon
1 plus x. It's
x.
ln of this. Ln of this.
Okay, 1 plus ln of x.
No, ln of 1 plus x.
Okay.
Ln of 1 plus x whole divided by x, as x tends to 0.
Or x tends to, I guess this, for this you'll get something in the form of exponential, I guess.
The limit calculated was 1, like, but how? I need to think.
Limit was 1.
Yeah.
Yes,
this
use L'Hopital rule.
no, one more thing. Is this ln 1 plus x only, right? Or there's something different?
No, it's ln log 1 plus x to the base e.
Yeah,
Okay.
Yeah, that's the thing. ln means log to the base e is ln. So that's
So see, for this case also, if you're putting x equals to 0 here, you'll be left with ln 1 upon 0, right? So this is also 0 upon 0 form. So you can differentiate both the cases. You just should be knowing what is the differentiation of ln 1 plus x, okay? Because the denominator part will be 1 only. So if you are differentiating, what is the differentiation of this?
1 upon 1 plus
1 by 1 plus x.
1 plus x. So if you are putting the value of x here, you'll be left with 1, okay?
Yeah.
So 1 is the answer. Is this clear?
So
yeah.
this is L'Hopital, right?
Yeah, this is a L'Hopital, whatever you call.
And
So
the
you can
like
use
the convention ways to like how
conventional way you can solve it like that. Again, you have to use, for this case, I guess the sandwich method will work here. So it's
can we
like for
discuss that sandwich?
sandwich method is like see, if you have a function and do not go into sandwich method, is just most of the time you'll not be able to solve with that method, that I can assure you. See, sandwich method is like you have to first think of two function at least, okay, two functions such that that is limiting, getting closer to some, that is converging towards some particular value, okay, and if that is converging towards some particular value, then only you'll be able to use the sandwich method. So what I'll suggest you to, most of the time what I feel is sandwich method will work every time, but you will not be able to solve with that method, that I can tell you. So it's better to go with the L'Hopital's rule to solve any questions, or maybe the basic approach to solve the method, okay.
So it's like for the complex problems we have to use that sandwich.
No, complex method will not be
That
able
one
to
is the
use.
easier when
Correct.
you able to think of the two converging functions.
Function,
That
correct.
that would cover this given function.
Correct. So sandwich method, you can use it whenever you have a simplest equation, okay. So for any complex and all things now, always go with the basic approach. The basic approach means what? You have been given some function fx and gx, so apply, if you have been given limit, okay, so go apply limit in both the cases, limit of fx, limit of gx, and every time if it is a combination of some two different like arithmetic, like two different operations, okay, so every time see if this fx is in the form of ax plus bx plus cx, so you have to apply the limit on all these cases, ax, bx, cs, all those cases, and then use, and each and every, so see, the best part about limit is you can split all those functions, and after splitting all those functions also, you just have to calculate the limit, how does that ax behave. So whatever the limits you are getting from a, b, c, you can do the same arithmetic as it is and then calculate the value. So this is the basic approach to solve that. And each for each solving each and every, for solving the limit of each and every function, you can use those L'Hopital's rule, you can use it, okay, to solve those cases.
Or
Okay.
like
Or see, or you can just remember some standard limit, like I told you, some of the standard limit we have calculated, like see, sin x upon x, or cos x upon x, or tan x upon x, or for the 1 upon 1 ln 1 plus x. So this, if you are able to know this, right, so your function will be the combination of all these functions itself, okay. So if you just remember those 10 or 15 limits, you will be able to solve without doing anything. You just have to split those functions, and if you are able to split those functions, you will be able to know that, okay. Is it clear?
So
Is it
like
making sense? Yeah,
it's making sense, but I want that sandwich how to use that. Can you take a simple problem and apply
okay,
that?
let's so let's see that. Let's, for example, you have a sandwich method, okay. So let's, for example, you have a function fx, and that is tending to L, okay. Similarly, you have a different function limit x tends to a gx, and that is also tending to L. And now if you have a hx as a different function, and that is lying between gx and fx, then you can directly say that hx is also tending toward L. So this is what I was saying. You should be knowing about the fx and gx to calculate the limit of hx. Okay. See, now let's take in one example. ln x upon x, limit of x tends to 0. For this function, I can think of two different functions.
Sir,
One
your
as a
voice
x.
is breaking.
Is my voice breaking?
It's okay for me, sir. Keep going.
For me as well, it's okay.
Okay. See, for this function now. So for this function, ln x, let's take base as e. Okay. So this is your hx, right? Now you have to take two different functions. We have to think of two different functions, fx and gx. Okay. So let's take one function as x and one function then x upon 1 plus x.
So
Okay.
we need to like create this and imagine or what?
Correct. You have to think of two different. That's why I was saying.
Then this is the
difficult function. You'll not be able to use this function. That's the. So this
no,
will work
it's
only
like
if you have.
putting more effort. Like
Yeah. This is what I was saying. So most of the time you'll not be able to use this because you'll not be able to think of that function.
so why does it even exist? Like it's of no use.
It's like of
It's
use
very much
because
of use.
if you have this is method because see if you have a two different function and then you have to calculate of a one function that is lying between two, then you can directly say that, right? So see, this is sometimes you can use it like for this function we can use it because for this function we are able to think of this is lying between x and x upon 1 plus x. Okay.
How did you like identify this?
After solving so many questions, you'll be able to know some of the methods.
Okay.
Okay. So this is how, and then
So
Got it.
it is more like guessing. So we have to like if
I
you
told you in
analyze
the
the graph.
it's like sandwich is like it's a difficult one to solve like using a sandwich method.
So
Okay,
now
see.
I'm just thinking like if a limit of a function does not exist, say at 2, so why don't we just plug in the value 2.000001 and be done with it?
So this is what basically we calculate in the limit. We calculate the value in the neighboring. We doesn't calculate the exact value.
Yeah, that's what saying like if we are able to do that numerically, so what's the advantage of these methods like
Which
distinctly?
method?
Like when we are saying that we need to calculate a function value at 2 of a function limit at 2.
Tends
So
to do.
yeah, so we can just plug in the value of 2.000001 and
You
what's the
can do
value?
that also, but more or less like it will not work. Most of the time it will not work. It will work, but you'll not be able to calculate it. See, for this method itself, you can use it to you can put it some values greater than 2, okay, and then calculate it. How will you calculate that value? Can you give me a method? So the calculation will be a bit tedious, right? It's better to use some standard method that has been given to you.
Yeah.
Basically, we are calculating the same thing, whatever you're saying. We are just going closer and closer to 2 and then calculating the value. Because at 2 itself, you can see directly at 2, so it's not existing. This function at 2 is not existing. But I have to calculate a value neighboring to 2. Okay, so neighboring to 2, I am calculating the value, and neighboring to 2, I am able to calculate it. There are some standard method to calculate that. Okay.
Okay, sir.
This is what we are doing.
Sir,
Yeah.
what if the function doesn't become 0 by 0 or infinity by infinity?
You can use that L'Hopital's rule directly. No, I told you that.
If it is not 0 by 0 or infinity by
Go with the basic
Then use
method. I
the
told you, right?
factorization or anything, then you will get that.
Factorization will work. So I told you, right? This function fx. Let's, for example, this is a limit when given to you.
factorization.
See, to solve limit, the 2-3 things you have to should be knowing. At least you should be knowing the standard limit. That you have to remember that. You have to mug up that. Okay, or you should be knowing how do you get that. So one of the two should be knowing. 2 is differentiation of some standard thing. If you are using the L'Hopital's rule, you have to know the differentiation of some standard function. Okay, if we are knowing out of these two, we'll be able to solve that. Okay, and the third is the basic approach, like if you have been given some equation in the form of like fx upon gx. Okay, and fx is in, let's for example, there is a function fx, and that is like x cube plus 5x square something, and x tends to infinite plus x, and then you have x to the power 5 plus 4x4 plus x square. How will you calculate that? Here will not. So here also you can use that L'Hopital, but why will you use that? Because here you can directly see that there's a degree of this is very large, right? So you'll always be getting 1 upon infinite type of thing. So the limit for this function will start tending to 0 itself. Right? Is it clear or not?
Yes, it's clear.
Yes, sir.
Is it clear for this function? Because you can see directly, right? For this function, though, you can directly see that. So you can divide. See, the basic approach means what? See, if you have x to the power 5, you can divide x to the power 5 with all the values. And if you are dividing x to the power 5 with all the values, you are left with what? 1 upon x squared plus 5 upon x cube plus 1 upon x4 upon this is what? This is 1, and then you'll be left with 4 upon x plus what is that? 1 upon x cube. Correct? This is the basic. So you have divided with x to the power 5, and then so this is a different function, this is a different function, this is a different function, this is different. Okay, and now if you are seeing that this is tending to 0, this is tending to 0, this is tending to 0, this is tending to 1, 0, 0. So 0 upon 1 is 0. Correct? Is this clear? Is this making sense?
Yeah.
How do you calculate the limits and all?
Yes, sir.
Yeah, there are some standard method. L'Hopital rule you can use or go with. So it depends on the question. Okay, how does it came? Like if it is in the form of some trigonometry, try to first see that whether it is in the form of 0 and 0. And if it is in the form of 0 and 0, you can directly use the L'Hopital. Okay, if not, then use the standard limits that you know, because the standard limit can be used because you already know that you can split the limits. Any given bigger limits has been given to you, can split those limits. And if you're able to split that, you can get it. And in the exam, you'll be asked mostly about the simple questions only. That has been, so 4 or 5 standard that you know. With the help of those 4 and 5 standard limits only, jumbled one will be given to you, where most probably you'll be able to use the L'Hopital's rule, you'll be able to use it. So you can practice some questions, not much. Like mostly, if you can just go through the previous term papers now, you can see that you can get a broader idea which type of questions will be asked. You'll not be asked about any difficult one where the log or the exponential will be included, where e to the power infinite or e to the power 0 concepts will be used. So those concepts we are not teaching, so we'll not be asking.
Sir, one question here. Sir,
Yeah.
So here we are using this type, like if we given the polynomial functions above and below, like x cube plus a. So we are just pulling out x to the power 5 and dividing the whole.
Correct. That's the basic
determined
approach. That's
denominator.
the first approach
Yeah.
that you should be using. Yeah.
Yeah. So is it applicable to any limit? We are asking, like if we are asking
Any limit, yeah,
like
you can use it.
x to the 2, yeah, x to the 5.
If yeah, you can use this method every time. You can divide it to get an idea. Yeah, this method you can use it for those cases wherever you are getting the function in the form of algebraic one, not the trigonometric one. Okay, so you can use this method.
Yeah. So if we are asking that find the limit at x tending to 5, then can we use this?
X tending to 5, you can't use. You can just directly put it the value.
Yeah. Just directly we
See,
can.
whenever you are able to put the value directly and you are not getting anything else, you can directly tell the value itself. See, if you have been given a function fx, x tends to 5, 5x plus 4, what should be the value? You can directly put the value here.
Yeah,
Because
like 29.
While putting the value, you are not like, see, when you were using a different approach, whenever you were getting something like this, 0 upon k upon 0.
Yeah, something
Right?
undefined form.
Undefined, or where you were not able to get the exact value. So in those cases, you were using some other tricks to solve this, to get the limit, right? But for those
Okay.
cases where you can directly get the value, why will you use those methods?
Yeah, because every time we do something with the functions, then we get the another function which is not the original type. So that's why I asked.
See, if you have a function like this, limit tends to infinite, and if you have been asked to calculate 1 plus x upon x square, what is the value?
It would be
It will tend to 0, right?
Yeah, 0 actually.
So here it is 0 because you can directly see that you can divide it with x square itself. It's divided 1 upon x square, and then you are left with 1 upon x. So this is also 0. This is also 0. Correct? Similarly, if you have a questions like limit x tends to infinite, x tends to 1, and if you have been given 1 plus x upon x square, then you can directly put the value. Why do you have to do anything, right? You can directly put it 2 upon 1. This is 2. So this is the method. Okay, let's solve. This is the last question that we are solving today. So limit x tends to infinite, x to the power. So this is 2024, right? 24 plus x to the power 2023 plus 1 upon same x to the power 2024 x to the power 2023, and then you have a no. So one thing I have left with 2024 x to the power 2023 x to the power 2022, and then you are left with 2023. What should the value will be getting? 1. I don't think so. We'll get 1. I guess we'll get something else.
0. Limit tends to 0.
No, sir. It should be 1. Like if we do
because
Yeah.
we have the
2024 times differentiation, we will left with only 1 in the numerator and 1 in the denominator.
because we are having the degree of numerator is 2024 and denominator also 2024.
Yeah,
So
that's what you
take the
said.
coefficients.
Yeah, if I go on differentiating numerator and go on differentiating denominator also, at last I will get only 1, 1.
Okay, let's reduce this 2024. Let's make it a smaller one. X to the power x square plus x plus 1. The denominator part would be x square plus 2x plus 2, correct? This is what I have written. If I start with 2, 1, 0, okay, and then 2 and 2x came here. Yeah. Okay.
So basically, you are scaling
Sir,
down
one.
to 2023 to 1. So
It's also 1, sir.
yeah, that's also 1.
There's no form of infinite by infinite. So I'll just differentiate it 2x plus 1 upon 2x plus 2.
Yeah, every time we differentiate, we get the power times power factorial, like 2, then 1. Then
It will depend on the quotient, sir. If
So for this case, though, you are getting 2 upon 2, 1 only. I guess for this case.
no, sir. In the similar case below 1, if I have a quotient niche in the denominator is higher or it's not the same, it may not be 1, right?
Sir, after another differentiation, the coefficient will be like 2024 factorial in the numerator also, in the denominator also. And
yeah,
both
that's what I
cancels
think.
out. And both cancels out because both are equal. That's why it's 1.
Yeah, if the case would be like x square and below is 4x square, then your limit will become 1 by 4.
There will be 1 by 4. See, why the values here? So for this case now, so whatever you have said, the factorial get, whenever you are differentiating, you get the factorial for sure. And here will be n minus 1 factorial. And if you will differentiate it here, there also it will be n factorial, I guess. Here you should be getting 2.24, I guess.
No, sir. Look, the power of highest term in numerator and denominator is just 2024. So if we differentiate it 2024 times, then we will get only 2024 factorial. Same for the numerator and same for the denominator. Rest of the x power are less than 2024, so they will diminish after like another differentiation. So 2024.
No, see. See, here also you'll get n factorial, correct?
Yeah, and
Here also you'll get n factorial.
no, but after like so after 1 plus differentiation, this will like x will vanish, and after that when we are vanishing this x to the power 4,
1
na?
second. Is 20, 24, correct? You are differentiating, correct? So you'll be left with x to the power 20, 23, correct?
Yeah.
Plus again, this is you'll get it 20, 20. So whatever you are getting. Okay. So this is basically you'll get in the same pattern. But here you are left with 2024. Again you are getting 2024. That is fine. But here you are getting 2024. It's multiplied already.
2024 into 2023 into x to the power 2022.
Correct. So 2023 x to the power 2022. So that means for 2024.
So powers are different. We cannot add.
What?
No, but the last one, sir, right? Last but one differentiation. The second one will vanish, right? Means that will only remain the constant. Correct? Whatever number it should come, 2024, and that will be a constant term, and the last differentiation, it will make it 0. So you will still left with the highest value of the x, right? That term will only left in both numerator and denominator.
Okay, leave that. But whenever I used to solve, because when like I did it like long back, but in the 12th or in the first year, whenever this type of pattern, mostly you'll be getting this type of answer, not one.
In that case, the denominator should be starts with the x to the power 2023, and numerator should be the 2024.
So what I was saying is, see, I'll just try to give you an idea. You can try it out at after the session also.
Multiple times L'Hopital rule apply.
You have to apply multiple times, mostly like 20-24 times. It will be some 20-24 ka factorial.
Yeah.
Okay, and then you'll be left with you'll be left with 20-24 ka factorial only. And here you'll be 20-24.
Also, yeah.
Okay, maybe then I'm writing it something wrong, I guess.
Yeah, because here the degrees are the numerator and denominator is same.
Okay, maybe I'm writing something different, I guess. Okay, leave that. I was just thinking, okay, there are some method, like one question I used to solve, like we used to solve mostly, right? So where we used to get the answer as a different, not the one or something. Okay, maybe I'm writing something.
In the JEE every year.
We
get this type of question.
Correct.
So why it is not 1 by 1? Not 1.
That's 1 by, see, the question that I wrote is incorrect. Okay, so I'll have to reframe it, I guess. Okay. But mostly whenever you have this type of problem where you are getting infinite by infinite or 0 by 0, try to use that L'Hopital's rule only. You'll be able to solve that. So 1 plus x square, and then you have 5x square plus 1. So here you can directly get 1 upon 5, the coefficient itself. Correct? If you have limit x tends to infinite. Okay, what you can do is try to solve some problems.
We use the L'Hopital method when.
Yeah, so here you are getting directly infinite by infinite, so you can use it directly. try to get some questions, try to solve some limit that includes some trigonometry basic and some standard that we have discussed, at least 4 5, that whatever limit we have discussed, try to solve those type of problems. I'll try to give you one sheet where you have some standard 10 standard limit and some 5 step differentiation that you can just if you are knowing those, I don't think so there will be any problem in solving most of the problems. Okay.
Yeah, okay.
Okay, so we'll just wrap it up in the session now. But yeah, try to solve some limits from anywhere, wherever you're getting. At least the best source is to the graded assignment practice. If you are finding it difficult, some questions can be, but try to go and see the previous some paper. That will give you a best idea. Solve at least those problems. You have to solve it anyhow. If you have a doubt, you can just ask me or any in any of the sessions. Okay, at least solve those problems. That will help you a lot. Okay, and I'll go through the statement, whatever somebody was asking, that statement I'll go through.
So the limit one, I was now I got clear when you gave the example now. That got clear because the professor was not saying about like this discontinuity thing. Just the like framing was I was not able to grasp initially, but after you give a few examples of this discontinuity now, after that I was able to understand that.
Okay. So yeah, so that's only I want to say that it's like try to solve some problem from the limits. I'll discuss the continuity differentiability also in the coming session. But at least I guess tomorrow you have a session. Try to solve some problem. Come up with all your doubts. Okay, regarding the limit. Take some questions from some of the standard books or maybe the NCERT of class 12th, I guess, or 11th. I don't know. Yeah, class 12. You can refer those. Or if there are enough questions in the graded and practice even in the activity, you can try to solve those and try to solve the previous term paper. Come up with all those questions. You'll get a good chunk of questions from limit, continuity, and differentiability in the quiz. Okay, and almost 50 or maybe more than 50% of the questions will consist of only this concept.
So
Okay.
I was having a bit trouble like on understanding also this some functional notations. Like I've shared you in the chat. Like I try to like understand that based on the input values and the output values, how like this sometimes this implication statements are written. Like if x1 is equal to x2 implies f of x1 equal to f of x2. This type of statements are in some of the questions. In that I created a table. Could you check like if it's correct or do I need to make some corrections?
Okay. What is that? What have you written here? A x1 equals to x2, f x1 equals to x2. What is this a and b? Which a and b is the different function. What is this t?
So t means truth, means it's valid. That is x1 is equal to x2. And if it's saying b is true, means f of x1 is equal to f of x2. So I like try to understand this relation based on that predicate calculus thing, no? Predicate. Because we use the implication thing. So that came to mind that I should summarize it in the table of this relation that we have studied.
What is the second one? This is not a function.
Yeah, it's not a function because for the same x value, we are getting different y values, different output value.
Okay. This this table I'm not able to understand it, but okay, if you have written it, if you are able to understand that is fine. But you can specifically ask like how do we define one and one or onto one, like onto function and all. But this
Yeah,
table.
that thing actually I need to understand. So if you can please go Like explain this, like how, like what is the condition if we are writing in terms of equality of x and equality of f of x, that it always ensures that it is a valid function, whether it is a valid or one-to-one function or not.
Okay, so this maybe we can discuss in the tomorrow's session. Okay.
Yeah, that will be great, sir.
Okay, thanks. So you can just come up with all your doubts. Maybe this will start with the 1, 1 and 1, 2, and then we'll discuss the remaining. So try to solve at least some problems from the limits and all. That will give you an idea. So I already told you most of the problem in the quiz, maybe 50 to 60% will be just from the limits and continuity.
Okay, sir.
Okay.
Great. Okay. Thank you, sir.
Yeah, so I'll discuss it tomorrow. Ankit, right? Okay.
Yes, sir.
Okay. Thanks everyone for the joining the session. We'll meet again tomorrow.
Thank you for the session, sir.